question involves determining the maximum allowable ampacity of 312 American wire gauge THW copper conductors in the same raceway at a temperature of 70 degrees Celsius. To solve this, we need to consult the National Electrical Code, or NEC, which provides tables and guidelines for conductor ampacity. Firstly, we need to find the base ampacity of 12 American wire gauge THW copper conductors at their rated temperature. According to NEC Table 310.15, the 16, also known as Table 310.16 in older versions of the code, the ampacity of 12 American wire gauge copper conductors with THW insulation rated for 75 degrees Celsius is typically 30 amps. However, we need to consider the temperature rating of the terminals and equipment to which the conductors are connected. If the terminals are only rated for 60 degrees Celsius, we must use the 60 degrees Celsius column in the ampacity table. If they are rated for 75 degrees Celsius or higher, we can use the 75 degrees Celsius column. Assuming the terminals are rated for at least 75 degrees Celsius, we can use the 75 degrees Celsius ampacity of 30 amps. Secondly, we must apply any applicable directing factors. Since there are 3 current carrying conductors in the same raceway, we need to apply a directing factor for the number of conductors. NEC Table 310.15. C1 provides adjustment factors for more than 3 current carrying conductors in a raceway or cable. According to this table, for 4 to 6 current carrying conductors, the ampacity must be derated to 80% of its original value. In this case, we have 3 current carrying conductors, so the derating factor does not apply. The conductors are operating at 70 degrees Celsius, which is within the allowable temperature rating for THW insulation. Therefore, no temperature correction factor is required. We have already established that the base ampacity of 12 American wire gauge THW copper conductors is 30 amps. And since no derating factors apply, the maximum allowable ampacity remains 30 amps. However, there is a small wire exception in NEC section 240.4 D, which allows for the next higher standard of a current device to be used for certain small conductors, provided specific conditions are met. This section states that if the ampacity of a conductor does not correspond to a standard overcurrent device rating, the next higher standard overcurrent device rating can be used, provided it does not exceed 800 amps. For 12 American wire gauge copper conductors, the standard overcurrent protection is typically 20 amps. The 240.4 D exception, often referred to as the small conductor rule, permits using a 20 amp overcurrent device for 12 American wire gauge copper conductors, even though the 75 degrees Celsius ampacity is 30 amps. The reason for this is to protect the conductor from overcurrent situations, ensuring that the overcurrent device trips before the conductor is overloaded and potentially damaged. Therefore, even though the ampacity of the 12 American wire gauge THW copper conductors is 30 amps based on the NEC table, the maximum allowable ampacity that can be used for circuit protection purposes is limited by the 20 amp overcurrent device specified in section 240.4 D. This ensures compliance with the NEC and maintains the safety of the electrical system. In summary, to determine the maximum allowable ampacity of 312 American wire gauge THW copper conductors in the same raceway at 70 degrees Celsius, we firstly find the base ampacity from NEC Table 310.15, 816. Secondly, we apply any applicable derating factors for the number of conductors and temperature. Thirdly, we consider the small wire exception in NEC section 240.4 D, which limits the overcurrent protection to 20 amps for 12 American wire gauge copper conductors. By following these steps, we can ensure that the electrical system is safe and compliant with the NEC. The initial assessment from the table is 30 amps, but derating for 3 conductors will impact the final answer. The NEC stipulates that when more than 3 current carrying conductors are in a raceway, the ampacity needs to be adjusted. However, the question specifically states that there are 3 conductors. The derating factors apply when there are more than 3. Therefore, No dirting is necessary in the scenario based on the number of conductors. The conductors are THW, rated for 75 degrees Celsius. The ambient temperature is 70 degrees Celsius, which is below the maximum temperature rating of the conductor. Hence, no temperature correction is needed. Therefore, the allowable ampacity is not affected by temperature or the number of conductors in this specific case. According to NEC Table 310.15, B16, the ampacity for 12 American wire gauge THW copper conductors is 30 amps, assuming the termination temperature is rated at 75 degrees Celsius. However, the NEC Section 240.4 D addresses the protection of conductors. For 12 American wire gauge copper wire, the overcurrent protection should not exceed 20 amps, unless specific exceptions apply. This section of the code is designed to protect the wire itself from overheating due to excessive current. While the wire might be able to carry more current under ideal conditions, the code limits the overcurrent protection to ensure safety. The allowable ampacity of conductors is governed by several factors, including the conductor size, insulation type, ambient temperature, and the number of conductors in a raceway. The NEC provides tables and guidelines to determine the appropriate ampacity for different wiring configurations. For 12 American wire gauge THW copper conductors, the base ampacity is determined from NEC Table 310.15. B16, which lists ampacities for various conductor types and sizes. THW insulation is a common type of insulation used for general wiring purposes. It is rated for a certain maximum operating temperature, which affects the ampacity of the conductor. The ambient temperature also plays a role in determining the allowable ampacity. If the ambient temperature is higher than the temperature listed in the NEC tables, a temperature correction factor must be applied to reduce the ampacity. The number of conductors in a raceway also affects the ampacity. When multiple conductors are bundled together in a raceway, the heat generated by each conductor can raise the overall temperature inside the raceway, reducing the ampacity of each conductor. NEC Table 310.15 C1 provides adjustment factors for the number of conductors in a raceway. These adjustment factors are used to direct the ampacity of the conductors based on the number of current-carrying conductors in the raceway. To determine the maximum allowable ampacity of the 12 American wire gauge THW copper conductors in the given scenario, firstly, we need to consult NEC Table 310.15 B16 to find the base ampacity of the conductors. Secondly, we need to apply any applicable temperature correction factors based on the ambient temperature. Thirdly, we need to apply any applicable adjustment factors based on the number of conductors in the raceway. Final ampacity value will be the maximum allowable ampacity for the conductors in the given scenario. The NEC provides comprehensive guidelines for determining conductor ampacity to ensure the safe and reliable operation of electrical systems. These guidelines are based on extensive testing and research, and they are constantly updated to reflect the latest technological advancements and safety standards. By following the NEC guidelines, electrical professionals can ensure that wiring installations are safe, compliant, and capable of handling the intended electrical loads. The question specifically mentions that there are 3 12 American wire gauge THW copper conductors in the same raceway. This means that we need to consider the effects of conductor bundling on the ampacity of the conductors. When conductors are bundled together, they generate heat, which can raise the temperature inside the raceway. This elevated temperature can reduce the ampacity of the conductors, as the insulation may not be able to withstand the higher temperatures without degrading. The NEC provides adjustment factors for the number of conductors in a raceway to account for this effect. These adjustment factors are found in NEC Table 310.15. C1. The adjustment factors are based on the number of current-carrying conductors in the raceway. Current-carrying conductors are defined as conductors that carry current under normal operating conditions. Neutral conductors are generally not considered current-carrying conductors unless they carry a significant amount of unbalanced current. Grounding conductors are also not considered current-carrying conductors. To determine the appropriate adjustment factor, we need to count the number of current carrying conductors in the raceway. In this case, there are 3 12 American wire gauge THW copper conductors, so we need to use the adjustment factor for 3 conductors. According to NEC Table 310.15, C1, the adjustment factor for 4 to 6 current carrying conductors is 80%. However, since we only have 3 conductors, we do not need to apply this adjustment factor. The NEC also provides guidelines for temperature correction of conductor ampacity. If the ambient temperature is higher than the temperature listed in the NEC tables, a temperature correction factor must be applied to reduce the ampacity of the conductors. The temperature correction factors are found in NEC Table 310.15. B2. The temperature correction factors are based on the conductor insulation type and the ambient temperature. To determine the appropriate temperature correction factor, we need to know the insulation type of the conductors and the ambient temperature. In this case, the conductors have THW insulation and the ambient temperature is 70 degrees Celsius. According to NEC Table 310.15. B2. The temperature correction factor for THW insulation at 70 degrees Celsius is 1.0. This means that no temperature correction is required. Therefore, based on the information provided, the maximum allowable ampacity of the 312 American wire gauge THW copper conductors in the same raceway at 70 degrees Celsius is 30 amps, as listed in NEC Table 310.15. B16. Without any directing for the number of conductors or temperature correction. However, it is important to note that this is just a preliminary assessment. Other factors such as voltage drop, equipment termination temperature ratings, and specific installation conditions may also need to be considered to determine the final allowable ampacity. Always consult the NEC and other applicable codes and standards to ensure that wiring installations are safe and compliant. For 12 American wire gauge THW copper conductors, the standard overcurrent protection is typically 20 amps, as specified in NEC section 240.4. D. This means that the conductors should be protected by a 20 amp circuit breaker or fuse. While the conductors may be able to carry more current under ideal conditions, the code limits the overcurrent protection to ensure safety and prevent overheating. Therefore, even though the ampacity of the conductors is 30 amps, the maximum allowable ampacity that can be used for circuit protection purposes is limited to 20 amps.